Our objectives in this lesson are the following. Compute for the test statistic a population proportion. Differentiate critical value approach from p-value approach of hypothesis testing. And draw a conclusion on population proportions based on the test statistic and the rejection region. Let's have a quick activity. What to do? Analyze whether to reject or not to reject the null hypothesis. Use the graphs, z-tab, and z-com for reference. You know very well that the shaded area is what we call the rejection region, and the unshaded area is the non-rejection region. Let's have number 1. Our z-tab or critical value is 1.28. Our z-com or computed value is 1.35. And 1.35 lies to the right of the critical value, and it falls within the rejection region, so our decision is to reject. Number 2, our critical values are positive and negative 2.575, while our computed value is negative 2.111. Negative 2.111 lies to the right of this critical value here, and it falls within the non-rejection region. So our decision is do not reject. Last one, our critical value is negative 1.645, while our computed value is negative 2.215, and it lies to the left of the critical value here. It falls within the rejection region, so our decision is to reject. In deciding whether to reject or not to reject the null hypothesis, you can choose from two approaches. The first one is the critical value approach. We are already familiar with this. This is what we use in our lesson, hypothesis testing involving population mean. Here, the computed value is compared to the critical value, like what we did earlier in our activity. The red lines here are the critical values. And if the computed value falls within the shaded region, which is the rejection region, we reject the null hypothesis. Another approach that I am going to introduce to you today is the p-value approach. This time, the p-value is compared to the significance level alpha. If p-value is less than or equal to alpha, we reject the null hypothesis. If p-value is greater than alpha, we fail to reject the null hypothesis. This shaded area here is the p-value. I'll explain this more later. To give you a glimpse of the process, here is a diagram. So of course, first we state the null and alternative hypothesis, and then we decide on the significance level if in case it is not given in the problem. Third one, we decide on the test statistic and compute for its value. From here, you can choose from two options, either critical value approach or p-value approach. For critical value approach, you have to determine the critical value and compare that with the computed value found in step 3. If the computed value falls on the rejection region, we reject the null hypothesis. If you choose the p-value approach, the first thing to do is to determine the p-value. And then you compare that with the significance level from step 2. If the p-value is less than or equal the significance level, we reject the null hypothesis. Whatever you choose from these two approaches, it will yield the same decision and conclusion. I'll prove that to you later. For the meantime, let's dig deeper on p-value. P-value is the short for probability value. It is always written with italicized p and with spaces on both sides of the equal sign or the inequality symbol. It is a value between 0 and 1. In writing, we do not write 0 before the actual p-value. Example, we should write p is less than 0.05 instead of P is less than 0.05. So we do not write 0 in front of the decimal point. If possible, always use the actual p-values. Example, p is equal to 0.025. You may use the inequality symbols like p is less than 0.10 or p is less than 0.05 or p is less than 0.01 if you are using the limited tables of critical values. If p is greater than 0.01, use 2 or 3 decimal places. If you are going to use the z-table, it gives up to 4 decimal places. I'll show you later. If p is less than 0.01, it should be expressed in 3 digits. Technically, p-values cannot equal 0. There are some statistical tools that gives p equals 0.000. Do not do that. Instead, write p is less than 0.001. If the level of significance is not given, we use zero point 0.05 as a threshold for p-value. So a p-value less than zero point 0.05 is statistically significant. It means it has a strong evidence against the null hypothesis. If the p-value is higher than the threshold zero point 0.05, it is not statistically significant. It indicates strong evidence for the null hypothesis. Let's know more about p-value. P-value is the measure of the strength of evidence against the null hypothesis. So the smaller the p-value, the stronger the evidence that the null hypothesis should be rejected. As I mentioned earlier, if p-value is less than or equal to alpha, you reject the null hypothesis. If it is greater than alpha, you fail to reject the null hypothesis. If alpha is not given, use zero point 0.05 as the threshold. Now, in a more understandable way, let us define p-value as the probability of obtaining a sample that is more extreme than the obtained test statistic, assuming the null hypothesis is true. To give you an idea, consider this right-tail test. Let us say this line here is the computed value 2.53. Where is the p-value? The p-value is the more extreme values. So if this is the critical value, the more extreme is the value to the right of it. So this shaded area is the p-value. If it is a left-tailed test like this one, and this is the computed value, the more extreme values are to the left of it. So this is the p-value that we are looking for. Now, how do we find p-value? There are several ways on finding the p-value. One is if you have a TI calculator like TI-84, you can use the normal CDF function there. Another way is to look for computer programs that give p-value. Or you may use the normal table, which I am going to show you now. So let's have an example. Here we are given the null and alternative hypothesis, as well as the computed z-value and the level of significance. So the first thing to do is to plot the computed value. 1.98 is somewhere here. Let us label that. Again, p-value is the more extreme values. If it is a right-tailed test like this one, it is the values to the right of the computed value. So here is the p-value that we are going to look for. To do that, let us bring out our z-table. Let us look for 1.98. So here is 1.9 and then 0.08. So the area is 0.4761. Remember that if you are using this particular z-table, this area is from the mean up to the particular z-value. So 0.4761 is from the mean up to 1.98. So this portion here, this is 0.4761. But this is not what we are looking for. We are looking for this area. You all know that half of a normal curve is 0.5. So to solve for this area here, we just have to subtract 0.4761 from 0.5. And that will give us 0.0239. This is the p-value that we are looking for. Now let us decide. Since 0.0239 is less than 0.05, the alpha level, the decision is reject the null hypothesis. Let us have another one. So this time we have a left-tailed test. Let us graph our computed value. Negative 1.07 is somewhere here. Let us label that. And the p-value are the more extreme values. So that would be the area to the left of negative 1.07. Let us bring out our z-table. Let us look for negative 1.07. Of course, there is no negative c values in this table. But since this is symmetrical, we are going to use positive 1.07 instead. So 1.0 and then 0.07 here. So the area is 0.3577. This area again is from the mean up to this z value. So this portion. We don't need this. We need this shaded area. So again, half of the normal curve is 0.5. So let us subtract 0.3577 from 0.5. And this will give us 0.1423. This is the p-value that we are looking for. Now let us decide, since 0.1423 is greater than 0.10, our alpha, the decision is fail to reject the null hypothesis. One more. This time we have two-tailed test. So let us graph 2.37, our computed value. Let us label that. Since this is a two-tailed test, let us also plot 2.37 on the left side. That would be negative 2.37, just to show that our p-values are divided into two parts. So the p-values are the more extreme values on the right and on the left. Let us bring out our z-table. Let us look for 2.37, 2.3, and 0.07. So the area is 0.4911. This area is from the mean to negative 2.37 and from the mean to positive 2.37. We need this area here. Let us use one side and half of the curve is 0.5. Let us subtract 0.4911 from 0.5 and this will give us 0.0089. This is the p-value here. But this is only on the left side. We also have here on the right side. Since this is symmetrical, the p-value here is also 0.0089. So to solve, what we are going to do is to multiply this by 2. And this will give us 0.0178. Now let us decide. Since 0.0178 is less than 0.05 our alpha, then the decision is to reject the null hypothesis. Now that you already know when to reject and fail to reject the null hypothesis, let us learn how to properly state our conclusion. Conclusion is the interpretation of your decision that includes three factors. Number one, whether there is sufficient or insufficient evidence. Number two, the level of significance. And number three, whether to reject or support the claim. So when the decision is reject the null hypothesis, you state there is sufficient evidence. There is sufficient because you reject. There is sufficient evidence at, let us say, 0.05 level of significance to reject the claim that, let us say the claim is that men prefer engineering courses than women. Or you may say there is sufficient evidence at 0.05 level of significance to support the claim that men prefer engineering courses than women. When the decision is failed to reject the null hypothesis, the word that you are going to use is insufficient. The reason that you fail to reject is because you have insufficient evidence. So you will state there is insufficient evidence at, let us say, 0.01 level of significance to reject the claim that men prefer engineering courses than women. Or you may also say there is insufficient evidence at 0.01 level of significance to support the claim that men prefer engineering courses than women. Take note that the decision is based on null hypothesis. Let us try this. So here we are tasked to solve this using critical value approach. Study and analyze the given data, then draw your conclusion. We are given here the null and alternative hypothesis, also the alpha level and computed value. Since we are asked to do this using critical value approach, we are going to need our z critical values. Alternative hypothesis states that less than 40%, less than, so this is a one-tailed test, particularly left-tailed, at 0.10 level of significance, so our critical value is negative 1.28. Let us plot that. Negative 1.28, somewhere here, let us label it. And the rejection region is to the left of it. Now, let us locate negative 1.87. It is somewhere to the left of the critical value, and it falls within the rejection region. So our decision is reject the null hypothesis. Now, how do we interpret our conclusion? Since we reject, it means we have sufficient evidence. There is sufficient evidence at 0.10 level of significance to support the claim that, what is the claim? That less than 40% of grade 12 students hate research. Now, let us do this using the p-value approach. This time, what we are going to plot is not the critical value, but the computed value. Negative 1.87 lies somewhere here. Let us label it. And the p-value, again, are the more extreme values. If it is a left-tailed test, it is on the left of the computed value. Let's bring out our z-table. Let's look for positive 1.87 instead, 1.8 and 0.07. So the area is 0.4693. This area again is from the mean up to negative 1.87. And we don't need this area. What we need to compute is the shaded region here. To do that, we know that half of the normal curve is 0.5. Let us subtract 0.4693 from 0.5. And this will give us 0.0307. This is the p-value that we are looking for. Now let us decide, since 0.0307 is less than 0.10, the alpha level, the decision is reject the null hypothesis. And for our conclusion, since we reject, it means we have sufficient evidence at 0.10 level of significance to support the claim that less than 40% of grade 12 students hate research. Notice that we arrive at the same conclusion even if we use the p-value approach. This only proves that whether you choose critical value approach or p-value approach, you will arrive with the same conclusion. Now, let us do extra challenge using critical value approach. We have here the null and alternative hypothesis, the level of significance, the sample size, and the number of successes. So we still have to compute for the z-value. So first, let us determine our P. Our hypothesized proportion is 56%. So P is equal to 0.56. Then let us solve for our Q, and that would be 1 minus 0.56, and that is 0.44. Let us also solve for our P hat, and that is equal to X over N. So that would be 177 divided by 300. And this will give us 0.59. Now, to determine if the sample is sufficiently large, let us solve for NP. Our N is 300. Our P is 0.56. This will give us a product of 168, and this is greater than 5. Now let us solve for NQ. Again, our N is 300. Our Q is 0.44. And this is equal to 132, also greater than 5. Let us add this two, and this will give us 300, our sample size. Now let us solve for the Z value. Let us substitute our given here. Our P hat is 0.59. Our P is 0.56. Again, our P is 0.56. Our Q is 0.44. And our N is 300. Computing this, it will give us 1.05. Let us continue. Let us recall our Z critical values. Since this is more than, so this is a right tail test at 0.01. So our critical value is 2.33. Let us plot that. 2.33 somewhere here. Let us label it. And the rejection region is on the tail of the curve. Now let us locate 1.05, and that is somewhere here. And it falls within the non-rejection region. Therefore, our decision is fail to reject the null hypothesis. Now, for the conclusion, since we fail to reject, it means we have insufficient evidence at 0.01 level of significance to support the claim that more than 56% of OFWs are female. For the summary, here are the things that we discussed in this lesson. Take time to understand this. Now, it is time to check your understanding. Pause this video for more time. Let us answer. This is the same problem that we did in extra challenge. Only this time, we're going to use the p-value approach. And let's find out later if we will be having the same conclusion. So let us plot our computed z value, 1.05. So somewhere here, let us label that. The more extreme values are on the right of the computed value. Let's have our z table. 1.05. Here is 1.0 and then 0.05. So the area is 0.3531. This area again is from the mean up to 1.05. So this portion here. To solve for this area, half of the curve is 0.5. So let us subtract 0.3531 from 0.5. And this will give us 0.1469. This is our p-value. Now let us decide, since 0.1469 is greater than 0.01, our significance level, the decision is fail to reject the null hypothesis. Since we fail to reject, so it means we have insufficient evidence at 0.01 level of significance to support the claim that more than 56% of OFWs are female. Notice that we have the same conclusion when we use the critical value approach earlier and this time the p-value approach. Gets? Our next lesson is solving problems involving test of hypothesis on population proportion.